We like tangent and cotangent waves. They're so happy. So the question was, when does tangent become undefined? Well, the definition of tangent, or at least one definition of tangent, is sine of theta over cosine of theta. So my problem comes in when cosine is 0. When this becomes 0, I get 0 in the denominator. And I'm going to get an asymptote. When is cosine 0?
Pi over 2.
At 90 degrees at pi over 2. So all I need to do to find the first asymptote for this is to take this value, 4 theta plus pi over 3, and I'm going to set it equal to pi over 2, because when this value equals pi over 2, I'm going to get an asymptote. So I'll subtract pi over 3 from both sides. That's 4 theta equals, that's going to give me a 1/6 pi. This is 3/6 and this is 2/6. Yes? So theta equals pi over 24. Lovely. So when theta equals pi over 24, I get an asymptote. So I'll come back over here. There's pi over 24. So there's my first asymptote. How do I find my next asymptote?
Just figure out the period.
Yeah, I figure out the period, and how do I get the period? Looking at this.
Oh, you pull out the 4.
I pull out the 4. Now I want to be cautious. Sine and cosine, what's the period?
2 pi.
Yeah, secant and cosecant, 2 pi. What's the period for tangent and cotangent? It's 1 pi. So you just got to be a little careful. Common errors there. So I'm going to say pi over k is my formula for the period. In this case, k is 4. So my period is every pi over 4. So I'm going to go out here, put another dotted line, put another dotted line. So this will be pi over 24 plus pi over 24 plus pi over 4. Well, if I convert this into 24ths, that's going to be 6 pi over 24. So it makes it 7. The period is pi over 4. No, 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 no. What's the period of tangent? Period of tangent is pi. Growl, growl, growl. So this is going to be 7 pi over 24. And so the next one, I'm going to add another 6 pi. It's going to be 13 pi over 24. Good enough. And now, what does a tangent wave look like? Well, it always crosses in the middle.
Oh.
Does it go this way or does it go this way?
The first way.
Yeah, the first way goes this way. I always remember it, even though they have nothing to do with one another.
X cubed.
I think of x cubed. X cubed goes that way. I think, oh, tangent kind of reminds me of x cubed. I know they're not the same.
And then cotangent would be the opposite.
Like negative x cubed, yeah. But that's how I keep them straight in my little mind. So I do that. I'm all done. And of course, I could make some over here, but I don't need it. This demonstrates that I know what I'm doing. I like these the best of all because they are the easiest. Yes?
How's the next one? 7 pi over 24.
Good question. We decided that our period was pi over 4. So our first asymptote is pi over 24, and we're going to add pi over 4 to it to get the next asymptote. Pi over 4, we need to get a common denominator, so we multiply by 6 over 6. That gives me 6 pi over 24 plus pi over 24. 6 pi and pi is 7 pi.
Oh, okay. Oh, so the
Yeah, that's probably, let me move this out of the way. I'm sorry, this podium is always getting in the way. Can you see that better, Emerson?
Yeah.
Probably can't read my writing that well either. This one's kind of sloppy, and so I added 6 pi here again. This one became 13 pi over 24 because I added 6 pi over 24 again. And you just repeat the pattern. Yes? Did you want to practice the sine wave, or we're getting close to the end of the period? Should we review inverses? Review trig inverses? Okay, let's review trig inverses.
Next class.
Go ahead and cut it there.